Okay, we're going to take a set of notes on direct and inverse variation. This is lesson 4.3b from Hawk's Learning. Something you're going to be seeing in every problem in this lesson is the constant of variation. The constant of variation. This is something that shows up in every problem, and it is an important value that you're going to have to find in order to solve the problem. The constant of variation we're always representing with a variable k. We're also going to see some wording that I want you to be familiar with before we get there. Varies directly as and varies inversely as. When something says it varies directly as, then you're going to see your k, constant of variation, being multiplied by something. K times something. So directly is going to mean k times something. When you see varies inversely as, then we're going to see k, our constant of variation, divided by something. So inversely means k divided by. Directly means k multiplied by. There's also going to be 3 steps that we're going to follow as we solve the problems. You're going to see a reading problem, and these are going to be the 3 steps that are going to allow us to make it through the problem. Step 1, you're going to write a formula using the constant of variation k. Step 2, we're going to solve for the constant variation k by substituting given values that are given in the reading problem. Step 3 is to use the value of k to solve for an unknown. So basically the question at the end is asking you to find something that is unknown. You're going to have to find k before you can find the unknown. So basically this is the way it will work. You will write a formula that is explained in the first part of the problem. Then you're going to have to solve for k. You got to figure out what does k equal by substituting in some given values. And last, now that you know what k is, you're going to use the value of k to solve for some unknown, which is solving the actual problem. Okay, so in example 1, it says, suppose that y varies inversely as the square of x, and that y equals 9 when x is 15. What is y when x equals 2? Round off your answer to 2 decimal places. Okay, so step 1 is to come up with a formula. So I'm going to try to help you decipher this and see how a formula comes out of this. Okay, y varies inversely as the square of x. That's describing our formula. Y varies inversely means y equals, inversely means k divided by, as the square of x. The square of x is x squared. So step 1, my formula is y equals k divided by x squared. Step 2, we have to substitute in given values to solve for k. So here's my given values. Y is 9 when x is 15. So I'm going to substitute those values. Y is 9 when x is 15. So I have just substituted into the same formula for x and y. Now I'm supposed to find what is k. What is this constant of variation? So in order to solve for my constant of variation, I'm going to multiply by 15 squared on both sides. So then k will equal 15 squared times 9, which is 2,025. Okay, so that completes step 2. Once I know what the value of k is, I'm ready to move on to step 3, and that is where we use k to find some unknown. So here's the third part of the question. It says, what is y when x equals 2? So I'm going back to the same formula. What is y? So this is my unknown. When x equals 2. So I substitute 2 in place of x. And now instead of using k, I'm going to substitute 2025. I know that k is 2025. So what is y when x is 2? I'm going to do this on the calculator. 2025 divided by 2 squared. And I get that y equals 506.25. It says to round the answer to 2 decimal places. So I'm going to keep that 0.25. So my answer is 506.25. And example 2. Suppose that y varies directly as the square root of x and that y equals 20 when x is 16. What is y when x equals 83? So again, we're going to go through these 3 steps. Step 1, come up with the formula. That is described at the very beginning of the problem. Y varies directly. Varying directly is going to mean k times something. So k multiplied by the square root of x. Okay, so y varies directly as the square root of x is y equals k times the square root of x. Part 2, or step 2. Substitute some given values and solve for k. So here's my given values. Y is 20 when x is 16. So I substitute for y and x, and I'm going to use this to solve for k. So we know that the square root of 16 is 4. So I divide by 4 on both sides, and k is 5. So I have now found in step 2 that my constant of variation is 5. Step 3, solve for some unknown using the k that we found in step 2. So what is y? Y is the unknown when x is 83. Well, k is 5 and x is 83. Round your answer to 2 decimal places. So I'm going to just use the calculator here and multiply 5 times the square root of 83. And I get 45 point, it's 552, so rounding to 2 decimal places is 0.55. So those are the easiest examples of direct and inverse variation. Now we'll get into some more difficult word problems. Okay, this one is written about Hooke's law. Hooke's law says that the force exerted by the spring in a spring scale varies directly with the distance that the spring is stretched. I'm going to stop there because that just described a formula. The force, which you can call any letter you want, I'm going to go with F, exerted by the spring in a spring scale varies directly, so I'm going to get K multiplied by with the distance that the spring is stretched. I'm going to call distance D. There is the formula that was described with that beginning of the problem. Now, step 2, we're going to substitute in some given values to solve for K. If a 7-pound mass suspended on a spring scale stretches the spring 4 inches, how far will a 15-pound mass stretch it? So this information here is the given values. A 7-pound mass, that's the force, suspended on a spring scale stretches the spring 4 inches, that's the distance. 4 inches. What would K be? Well, if I solve here, I divide by 4 on both sides. K is exactly 7 over 4. Step 3. How far will a 15-pound mass stretch it? 15-pound mass, that's like the 7-pound mass, that's the force. So 15 goes in the formula for F. K is 7/4, and we want to know the distance that it will stretch. So to solve for distance, we're going to divide by 7/4. So 15 divided by 7/4, and it says to round to one decimal place. I get 8.57, so I'm going to go with 8.6. So it should be 8.6 inches. Okay, example 4 says the safe load L of a wooden beam of width W, height H, and length L, supported at both ends, varies directly as the product of the width and the square of the height, and inversely as the length. Stop, that is a lot of information. But we're going to decipher it. First of all, it says the load L is what varies, okay? It varies directly as, so that means equals K times, directly as the product, the word product means multiplication, of the width and square of the height. So that's width and square of the height. Do you see how this is the product of the width and the square of the height? And inversely as, so it's going to be K divided by the length. This is the formula. Step 1 is to come up with the formula, and that's probably the hardest part of this particular example, is coming up with this really complicated formula. But when you break it down to the parts, this is the load L varies directly, that meant K times, as the product of the width and the square of the height. So the width and the square of the height is WH squared. And inversely as the length means K divided by L. So there's our formula. Part 2, we're going to substitute in given values and solve for K. So a wooden beam that is 6 inches wide, so we're not going to know what K is, but 6 inches wide, 8 inches high, so the height is squared, and 168 inches long, that's the length, can hold a load of 10,970 pounds. So that is L. We're going to use that information to solve for K, our constant of variation. So I'm going to begin by multiplying both sides by 168. That cancels on the right side, leaving me with K times 6 times 8 squared, that is 64. And then 168 times 10,970 is a really big number. 1 million. Oops, undo that. 1,842,960. Okay, and then I'm going to multiply 6 times 64. That is 384. 384K equals 1,842,960. Divide by 384. And I get K is equal to, now here is a point at which that I got a decimal. And I want to look at the answer. It says to round off your answer to the nearest integer. But that's the answer. That is not the constant of variation. K, the constant of variation, make a note of this. You should not round. Do not round. Okay, you need to be exact with your constant of variation. So I got 4799.375. Or I could push Math Enter and convert that to a fraction on this calculator. Or, but I'm just going to work with that as a decimal, but I'm not going to round that. K is not the answer. It is a constant of variation that we use to find our answer. If I round K, then my answer is not going to be accurate. It's going to be close, but it won't be accurate. So do not round the constant of variation. Okay, so that was step 1 and 2. Step 3, it says, what load would a beam that's 4 inches wide, what load would a beam that's 4 inches wide, 6 inches high, and 192 inches long of the same material support? Round off your answer to the nearest integer. Now, K, we learned, is 4,799.375. So this particular calculation will give us what L is, what our load is, okay? What is the load this beam would support? So you should be able to type this all in the calculator in one step, which is what I'm doing now. And I got 3599.53. Now, again, the answer here, it asked me to round to the nearest integer. So this 0.5 means I'm going to round that 99 up to 3,600. So 3,600 would be the load. Okay, moving on, example 5. The volume of a gas in a container varies inversely as the pressure on the gas. Stop. The volume of a gas varies inversely, so it's K divided by, as the pressure on the gas. So I'm using V for volume and P for pressure. Step 2, substitute in values that are given. If a gas has a volume of 158 cubic inches, so 158 is the volume, under a pressure of 3 pounds per square inch. Okay, this is for pressure, we're substituting 3. Okay, this is where we substitute, and we're going to solve for K, our constant of variation. So I'm going to multiply both sides by 3. So K will equal 158 times 3, or 474. So my constant of variation is 474. Part 3, step 3, what will be the volume if the pressure is increased to 6 pounds per square inch? So pressure is 6. We know now that constant of variation is 474. We do 474 divided by 6, and we get a volume of 79 cubic inches. It says round to the nearest integer, and that one was exact. 79 cubic inches. Example 6, the distance that an object falls from rest. Distance that an object falls from rest when air resistance is negligible varies directly. So K times varies directly. Distance as the square of the time that it falls. Square of the time is T squared. A stone dropped from rest, so we're moving on to step 2. A stone dropped from rest travels 80 feet in the first 2 seconds. So its distance is 80 feet, and its time is 2 seconds. So we have substituted into our formula, and we're going to use this now to solve for K, our constant of variation. So 2 squared we know is 4. Let me undo that. Okay, 2 squared we know is 4, so I divide by 4 on both sides. So then 80 divided by 4 is exactly 20. So K is 20. Now, it says how far will it have fallen at the end of 5 seconds? So what would be the distance? How far at a time of 5 seconds? So our K, we said, is 20. And our time is 5 seconds, and we square our time. So 20 multiplied by 5 squared is 500. It says round to the nearest integer, and that is an integer. So 500 feet is our answer here. I'm going to talk through it. Let's see. Example 7. The gravitational force between an object and the Earth is inversely proportional to the square of the distance from the object to the center of the Earth. So we're going to stop here and try to write a formula. Okay, the gravitational force, I'm just going to call that F. No, I'm not going to call that F. The gravitational force is your weight. We're going to call that W, your weight. Between an object and Earth is means equal sign, by the way, inversely proportional. So it's going to be K divided by to the square of the distance from the object to the center of Earth. So inversely to the square of the distance. That distance is representing the distance from the object to the center of the Earth. And I'm going to draw your attention to this. At the end of the question, it says assume the radius of the Earth is 4,000 miles. So that means from the surface to the center, it's 4,000 miles just from the surface of the Earth. Okay, now let's get into our finding K. If an astronaut weighs 205 pounds on the surface of the Earth, so the weight would be 205, that's the force. What will he weigh 180 miles above the Earth? Hold on a second. This is on the surface of the Earth. Okay. So we don't know K, but what is our distance from the object to the center of the Earth? If we're on the surface, our distance right now is this 4,000 miles. Okay, now I'm going to draw a picture over here to make y'all think about it. So here's the Earth, and here is my lovely astronaut standing on the surface of the Earth. Here's the center of the Earth. The distance that he is from the surface to the center right now is 4,000 miles. Okay? So that's what this 4,000 in my formula is representing, his distance to the center of the Earth. Now, the second part of the question is what we're going to be finding. But before we do that, let's solve for K. So I'm going to multiply by 4,000 on both sides. So we got 4,000 times 205, which is 820,000. There's our constant of variation that we're going to use. Now, the second part of the question says, if an astronaut weighs 205 pounds on the surface, what will he weigh 180 miles above the Earth? 180 miles above the Earth would mean that this distance is 180 more miles out, and now our little astronaut is floating out here in space. 180 miles. I know this is not drawn to scale, but 180 miles out from Earth's surface. So now the distance, which is represented here in our formula, this D, our distance is not going to be 180. Our distance is going to be this total. Oh, I'm moving my astronaut. Okay, our distance is going to be this total, 180 plus 4,000. So the distance is 4,180. So we'll say, what will his weight be if his distance is 4180, and the constant of variation was 820,000. So we can then calculate this astronaut's weight if he is 180 miles into space. So it would be 196, and what does it say about rounding? Round to 2 decimal places, 196.17. So this astronaut that weighs 205 pounds, if he is 180 miles above the Earth, his weight is 196 pounds. Is that right? No, that's not right. Y'all let me do that wrong. That's completely wrong. What did Miss Moon do wrong? Miss Moon did a whole bunch of stuff wrong on this. So I'm going to backtrack and start over. So I knew that that was wrong because he should weigh far less in space. So where did Miss Moon make a mistake? Well, look back here at your formula. K over D squared, distance squared. Guess what Miss Moon didn't do anywhere else in the problem? I didn't square that number. So if we go back and square that number like we should have, we'll get a complete different constant of variation. So, backtracking. Sorry about that. That's why they make erasers. Okay. So, multiplying 4,000 squared times 205, I get much bigger constant of variation. 328 and 1, 2, 3, 4, 5, 6, 7 zeros. There's my constant of variation. So now, when I go back over here, all of this is wrong. Except that 4180. I was so worried about that part that I messed up the rest of it. 4180 gets squared, because it's inversely varied by the distance squared. But K was 328 and 7 zeros. Okay, now take that and divide it. And we get 187. 187 still isn't as small as I thought. 187.72. That should be correct. Okay, so I stood back and looked at that, and I do believe that we have the correct answer this time. Sorry for the mistake on the first time through. Now you see I am a human being that makes mistakes. So I'll just wrap up with a reminder that we want to follow these 3 steps. Step 1, we're writing a formula that uses a K, a constant of variation. Step 2, we're solving for K by substituting in given values. And step 3, we use the value of K to solve for some unknown in the problem. So good luck with your certification, and hopefully this will be of assistance to you.